Okay, so let's see. Let's pick up with number 8. Whoops. Okay, so 8, 9, and 10, you're learning how to do these problems so that you'll be able to put them in the calculator. Because you know how when you put in a function into a calculator, how you solve for y, and that's how the calculator insists that you put it in? Well, when you do polar graphs, you have to solve for r in order to put it in the calculator. So that's what these are practice at. Okay, so first thing you're doing in this problem, try to get yourself to the point where you're comfortable enough with the terminology here that whenever you see this word, you understand that they're either asking you to put it in XY form or that they've given it to you in XY form. That's what this means. Everything's in XY form. They want you to go to polar form. That means you should have all R's and thetas. Not necessarily R comma theta, but you should see nothing but R's and thetas in the problem. This is when you should see X's and Y's, when you see the word rectangular. So get comfortable with those phrases. Okay, so now comes the part where you try to pull out of your memory what you've memorized with regard to X. Okay, on the first page it said the equivalent of X in polar language is R cosine theta. You got to memorize those. Start memorizing them. And then it's minus equivalent of Y is R sine of theta. And then that's equal to 7. And then just as a little bit of practice to get it ready for a calculator, so in case you wanted to graph this, you solve for R. You have to know a tiny bit of algebra to get that to happen. You have to see that if you're trying to solve for R, but yet it appears in 2 different places, you got to get it to appear in one place, and that would happen if you just factor. Okay, so if you factor R out of there, then you can write this as cosine of theta minus sine of theta equal to 7. And now you can isolate the R because now the R only appears in one place. It's the factor that you pulled right out there. This says R times this expression, so you want the expression to go away, you do the opposite of what it says right now. Divide it right off of the R, this entire expression. And remember, whatever you do to one side, you have to do to the other side. And then that's exactly what you would put in the calculator. You would just put R is equal to, and you would enter that in the calculator. If I was going to enter that in the calculator, though, since there's 2 items, just to get you ready, for things that you should look out for, since there's 2 items in the denominator, I would just wrap it in parentheses. So that it calculates this value first, cosine of theta minus sine of theta, because your calculator is going to be plugging in the theta for you. And then you go 7 minus whatever that value in the bottom is. That's what the parentheses do. But as far as this problem, if you just give me 7 over cosine of theta minus sine of theta without the parentheses, that's fine. Okay, same thing here. All you're gonna do is try to remember what's equivalent to X and Y, and then get the R by itself. That's it. Okay, there was the formula all over the problems that I did, where X is the same thing as R cosine theta, but this says take your X and square it. Okay, then Y is the same thing as R sine theta, but this says take your Y, there's my Y, and square it. Okay, now you're going to, once you plug in, you're done, getting rid of the X's and the Y's. You're now in polar, but now you're going to work on your algebra. Okay, you're going to try and isolate the R. First, pull in the square. So it's R squared. There's 2 terms here. There's an R times cosine of theta being the other one. So it's R squared, cosine squared. Remember, the square goes on the trig word, not the theta. Likewise here. It's R squared sine squared. Okay, then if you're going to solve for R, yes? Yeah, I could have done it that way. I did it this way and did an extra step. You're right. I could have just went like that. I'll do that over here, but let me just finish it now since I already started it this way. So it is r squared, then you go cosine. I could have done this in less work. He was just trying to point that out to me. Sine squared theta, so this is sine squared theta. This is equal to 1. 1 times r squared. And then if you were going to solve for r, you would just go square root. And to get the graph of this thing, you would have to feed it in 2 different functions. You would have to go r1 is equal to positive 4, and then r2 is equal to negative 4. Because you know how when you're doing functions, how you go to graph and it says y1, y2, y3, and you can put in many functions at one time? Well, this just happens to be, and you know, because a function has to pass the vertical line test, right? So anytime something is overlapping like a circle, this is a circle, by the way. You just don't know that yet because you haven't done section 9.2 yet. So if you're doing something like a circle that has a top part and a bottom part that doesn't pass the vertical line test, you got to feed it in pieces. So just like you would have on your calculator y1, y2, y3, you also have r1, r2, r3, and you would go r1, positive 4, and then the second function, you would just let it be negative 4, and that would give you the top and the bottom of the circle.
So on the last one, you said we were saying incorrect activity, but I don't know how to do that.
Well, I will when we get to 9.2.
Oh, okay.
9.2 is all about graphing. They don't ask you to graph yet, but we'll do a whole section of that. Okay, the other thing he was saying that I could have done it shorter, I could have. This was, what did we start with? X squared plus y squared? Look on the front page. See that definition that they gave you right there? These are the ones that I keep using. But see that one right there? I could have used that from the beginning. So I could have just went the x squared, y squared that they gave me, and I could have just called it r squared. That way I would have had like only 2 steps. So I could have just went, that's equal to that, substitution, anytime 2 things are equal. And then I could have just went right into this step. So yeah, definitely do it with less work. All right. Next one, same thing. So it's 5. R cosine of theta. Get yourself start memorizing. You don't want to try and, please don't do this because I fear that this is what you tried to do in chapter 7. I know that when you are the age that you are heavy, did I say heavy? Procrastinators. And so what you like to do, because you also have this feeling of supernaturalism, hey, I'm supernatural. I'm like, I can memorize 17 million formulas the night before the test. Guess what all of you proved that you couldn't do on chapter 7? Do you remember those grades? 12s, 15s. Let's give praise where praise is due. You kicked it out of the park on the last one. Okay, you did really well. There was actually 23 A's out of this batch of people. There's about 30-something people in here. 23 people got an A. And many, many people got over 100. Many people. I would say there was about 12 of those. Those are people that did extra credit. Okay, that's been available for every single test. There was only 3 C's, and those were the lowest grades. I don't think this class had any D's at all or any F's. It was the 3 C's. Those are probably still the people that are thinking they're supernatural and that they can, because you really had no reason not to get anything but an A. Because it was all right triangles. You did really, really well. I wouldn't go nuts with praising yourself, though, because you need to be able to spin. That's the most important thing. Although, there was hardly any of that. There wasn't any of that in this particular test. But the main thing that you see keeps creeping back into every lecture almost every lecture that I talk about, where you spin to a quadrant, draw the triangle, and then go from there. So I want you to make sure that you're tight on that. Don't study the night before the test. You should be trying to, try to start memorizing these formulas. So that goes with that, that goes with that. There's 6. You're solving for R. Okay, so 5r cosine theta, this is r sine of theta, and same thing, just factor out the r. So this factor out the r there, it also belongs to that. This would be 5 factor out the r. This would be 5 cosine theta that would be left over. And then factor out the r here, which is right there. This would be plus sine of theta. And then divide it off so that you're isolating the r just like they asked you there. Express r in terms of theta. That means solve for r. And then just do it on the other side as well. Okay, that's gone, and then you're into that. Okay, any questions about the last three that I've done? Same thing on all of them. You're just solving for r. The second one was easier than this one and the first one. Okay, let's go to 9.2. Get your calculators out. We're going to graph by calculator. Okay, so these are what you're seeing on the front page right there are all the kind of shapes that you can expect to get. And the form of the equation that goes with it. Now, because of the time that you guys have allotted to each section whenever you take a college class, you basically have one day, one class that you're talking about that particular section. That doesn't give you a lot of time to learn how to do this by hand, so you're lucky. We do in this class, when you take it, and when in high school we do it by hand. I make them do like tables when they would learn how to do it, and we would spend about a week and a half, 2 weeks just on this particular concept. But you guys are just going to do it by calculator. It's okay if you do it by calculator because I already know what the heavy topics are in calculus, and they don't really care that much about whether or not you can do one of these by hand. So. You might have to look at a graph once in a while that's polar, but you're mostly going to be doing algebraic things on these equations. So what I'm sharing with you is just what you can expect to happen. These are the two different ways that you can see a circle. There's another one that's also a circle, which I don't know if I put it on here or not, but let me clear this up if I can. Okay, so based on, again, like on the form of the equation, when the cosine or the sine are first degree, and there's just a coefficient out here, this coefficient is actually going to be the diameter of the circle. So this kind of tells you the diameter and the radius, this number that's out here. Again, I don't know that you need to memorize that, because you're going to be getting the calculator to do it for you. You just need to be good at feeding it into the calculator. So what I just did in numbers 7, 8, and 9, or whatever, the last three that I just did, 7, 8, and 9, I believe it was, that's what you have to be able to do. You've got to be able to solve for R so that you can get it in there. You have to be able to mess around with the various windows that are available for trig-type graphing. So practice along with me as I go and do these. These are called lemniscates. They look like an infinity symbol. When it has the word sine in it, it'll be slanted like this in quadrants 1 and 3, and when it has the word cosine in it, it will be right along the x-axis. These are designated by, you will have a coefficient out here that you can take the square root of, and that's going to be how long these leaves are right here. It'll be the length that you'll go out that way. And there'll always be a double angle here. If you come down here, these are all called the limichons. And sometimes these limichons have a inner loop like this. I'll tell you how you would figure that out by hand, but again, you're not figuring it out by hand. And there's also a way that's really easy to figure out how long the outer loop is. So this has a length, and this one has a length. Those are pretty easy to figure out. So all of the limishons, whether they have that little tiny inner loop or whether it's missing, like this, is told by the values that are in the equation. All your limishons will look like this. And then I also want you to look at this thing. When you're doing a limishon, do you see how sometimes it has y-axis orientation? In other words, it wraps around the y-axis? That'll be because it has the word sine in it. You remember sine is y over r? Sine's associated with y. So it'll have y-axis symmetry. Something like this that wraps around the x-axis is because the word cosine will be in it. Does that make sense? Because of the definition that cosine always has to do with x. So it makes sense that if I give you an equation that is in this form, because all limishons are given in that form, they either have the word sine or cosine in them. See, there's one example right there. There's another example. So when I give you a limishon, it'll have a number here and a number here, either a plus or a minus, one or the other, not both. It's not like the quadratic formula. And then it'll either have the word sine, in which case it will have y-axis symmetry, or it'll have the word cosine, and then it'll have x-axis symmetry. Okay, notice that sometimes the apex comes right up into the origin, like this one does in this one. See, it hooks right in there into the origin, and sometimes it lags behind. That's called the limishon with a dimple. That little lag space right there that you see, that's called a dimple. And I can tell you how you would get that also, but again, you will not be doing these by hand. All right, so then we have what's called the roses. Now, I think there's specific questions in my math, I'm pretty sure, about how many petals. How many petals does the rose have? You could also call these leaves. Some books call it a leaf, some call it a petal. So I want you to understand that some of your My Math Lab questions will be answered by that right up there. See how it says when this right here is even to n number of petals, then you're going to have twice as many petals. Okay, so let's look at this. Let's say I give you something like this, and there's a even number right here, like say the number 2. You're going to double that, whatever this n value is, if it's even. And I know there's questions about this in My Math Lab. If it's even, like double it, and that's how many petals you can expect to see on the graph. So just kind of, if you know little things like this, it'll help you to see if what you're seeing in your calculator is actually accurate. Okay, if you see the number, odd number there, like a 3, then it's that exact number of petals. So when it's an odd number, that dictates the exact number of petals, but when it's even, you double it, and that's the number of petals. Your calculator is going to do that for you, though. So you don't have a whole lot. This is not a memorization section. You're not, at least this is a section where you're not memorizing formulas. Okay, get your oh, this was the other circle that I didn't have up there on all those collected ones. There's 3 different forms of a circle. All right, so get your calculator. You're going to be doing these in radian form. So switch your mode over to radians. I don't even have this page. Hold on one second. That's nice. All right, so go over to the calculator. Okay, so go to mode, switch it over to radians, and then see where it says function? I'm going to teach you this last, how to get parametric equations. Right now we're doing polar, so go over. That'll be the one thing we learned from chapter 10. We only do one section. So go over to polar. Make your calculator accept that. Press enter. Make sure you're in radians. Quit out of there. Okay, now go to where you usually put your functions in. When you're getting ready to graph, push y is equal to, and you'll see that they have all switched over to an r, because you've told it, hey, we're in the polar system, and there is no x's and y's in the polar system. So everything has switched over. Go put the number that you're going to put in there, which is 6, I think. Yeah, 6. Okay, press enter. This is going to be a circle. You can try trig window, see what it looks like, and then we'll also try square window. Now that's a little bit too big. So you could accept this the way it is. I mean, it's a nice graph. It's just that you can't see the top or the bottom, but you can see the sides. It's actually nice because you can see very clearly where it cuts through the x-axis, just in case somebody asks you, or through the poll actually, if anybody asks you a question about that. So you can just make it a little bit taller if you want to. You can also use zoom square. You can use zoom fit. Yes. You first. You put your hand up first.
I have a pentagon, so something is wrong.
You need to clear your memory. Because if any junk, if there's too much junk stored in your calculator, it's not going to graph for you any longer. It loses the ability to graph. Here, I'll show you how to clear, in case you have forgotten. Okay, you just go, and it should be okay after that. So you should go second memory, go down to where it says reset, all RAM, clear all memory, press enter, reset again, and see if that works. Try it again. Check your mode though first, make sure it's still the way we had it before. Nope, it switched over. It defaults to function form.
Okay, that fixed it.
Did it do it?
Yeah.
Yeah, usually that'll do it.
Kind of an oval, right?
Yeah, and if it didn't fix it, then your calculator may be fried. See, if you just do if you just let the calculator do whatever it wants, instead of having some kind of concept about what the shape is supposed to look like, this is supposed to be a circle, and the two circles that I did put on the front page, maybe you want to put it right next to it. It's just r is equal to some value. You can write it right on the front here. We're gonna make that look the way it is. We're gonna choose a different window. So why don't you, by the circles, you can put R is equal to A, where this is just some number. Whenever they mention A and B, it's because it's a number. So there's 3 different circles you could get. It could come in this form where cosine is linear with an A value out here. They can come in this form where sine is linear with an A value, or you could have the kind where there's no cosine or sine word at all, just R and a number. That's what A and B means. Whenever you see A and B, that just means a coefficient, an integer or a decimal or whatever. Those are the 3 kinds of circles. Okay, back to the calculator. Let's make this thing actually look like a circle. You can choose a square window. Square is when it's just as big this way as it is this way. That tends to round it out. Let's see if that works. All the windows are under zoom, like the pre-made ones. Let's see if that works here. We could also, there you go. So now let's see. Do you see that? You can tell that it's a circle because what do circles do? They're just as big going this way as they are this way. So do you see that that cuts in at, what, 6? So the number you're seeing, that's going to be the radius. You can put that in your notes if you want. Okay, let's go to the next one. Pick the answer to that problem. Which answer is it? Yeah, it has to be C. Okay, pretty darn obvious. Okay, go to number 2. Try putting that in your calculator. See if you get a picture that's like any of the ones that you're seeing. And I'll do it with you. see, 1 minus cosine theta. Yeah, let me tell you what you just graphed here. Hold on for 1 second. Yeah, it's A. But these are, you know, like if they look on the front page, I want you to tell me which one you think that is. And you can make this bigger also. Like if you wanted to make this like a little smaller, you could go, let's just mess around and see what the other windows. How about zoom fit? I mean, not that you can't pick out what you're doing right now, but I like this picture. That has detail on it. Do you see that that's one of those limichons? And I can rewrite for you because you might have to at least be able to tell me what this shape is called. It kind of almost looks like a clover leaf. So like if you were going to rewrite this so that it looks like the equations are supposed to look, this would be cosine of theta in its linear form, and then that was a positive 1. See, anything that has something added or subtracted to your trig word and your trig word's first degree, notice that all the equations on top of the limichons all had either sine or cosine to the first degree, no second degree, because the minute you go second degree, it turns into a different shape. So the limichons are always first degree. Remember I was telling you that when it had the word cosine, that it was going to wrap around the x-axis? Just in case any of you get caught on the day of the test with no calculator or something like that, sometimes you can just pick just from knowing little stuff like that. Your answer should wrap around the x-axis. Now you see that negative? That's right there. Which choice did you think this was? I don't know if any of them were close. I haven't even really looked at them yet. Yeah, it's A, right? So do you see how you got pretty much a limichon here and a limichon here that both wrap around the x-axis? That negative that you see in front of cosine in this problem means it goes in the negative x direction. It points off to the negative x direction instead of to the positive one. Okay, let's try C. All right, now there was something here. Remember we were talking about that whenever it's a multiple, right? If it was just theta, it would not be a rose. But the minute you start getting into 2 theta, 3 theta, 4 theta, it starts developing these petals or these flowers. So remember I was telling you that if this number is even, you double the number, and that's how many petals it should have. If it's odd, like let's say it would have been 3 theta, 3 petals. If it's even number, double it, 4, you're going to have 4 petals. So don't pick a picture unless it has 4 petals. It has to be this one or this one. Okay, the 6 that you see there is how long the petals are. They're 6 units long. Okay, put it in your calculator. You want to make sure that you can handle your calculator and that you're not going to lose points on something that nobody loses points on this because you're doing calculator stuff. So at least make sure you can do that. You don't have to know a formula, nothing. So get rid of this. It's just 6. And we'll mess around making sure that we just hit where the x is. And instead of an x, it'll give you a theta because it knows you're in polar. Oops, chopped it off. Let me go back and do, you can do zoom trig. Let's see what the different pictures are. I want to try zoom standard also, which is typically a window that you use for functions. Okay. Let's try this one. Which one?
Zoom square.
What?
The fat one's okay, but it's too oval, you know?
Yeah, something didn't come out right here. I don't think I pressed it in right. Let me go back to this. Yep, I didn't. What was that? What was there? 2 theta? I'm thinking, you see why it's good to know what the shapes are? Because the minute I looked at that, I was like, it's supposed to be a rose with 4 petals. All right, so 6 cosine 2 theta, press that in, blah, 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 blah. That looks kind of nice. I mean, that would definitely be enough, but I mean, some of it's chopped off. So I don't know what this gives. I'm just curious. That's a nice picture. That's a good picture, too. That's just zoom standard. Usually I use those for the XY graphs. But, you know, my point is you could use several of them. Would you use square? Square probably gives a nice picture. See, there's 6 units long. That's what that 6 was that was out in front of it. Anyway, answer here is, let's see, A. All right, let's go to the next one. Go over to the next page. Okay, what makes this one a lemniscate, it's an infinity symbol, is the fact that it starts with r squared. R squared means you have a lemniscate. All right, so let's practice. Let's talk about how you're going to enter it. I'm sure some of you already know how you're going to enter it, because obviously when you call up that window for the r's, there's no r squareds there, right? So you have to turn it into information. I think this is fairly obvious. That is acceptable by the calculator. All right, so you need to give it r, not r squared. So just take the square root, take the square root here. Don't forget that when you're solving an equation that used to be r squared and you're trying to solve for r, that you get plus or minus as the answer, or you're only going to get half the graph if you don't understand that. So this is going to be r over here on the other side, not where the squared term is. On the other side is where you do the plus or minus. Square root of that number that's in the front is 3. So bring it out as a 3, but leave the cosine of 2 theta inside, because you can't really take the square root of that without turning it into some kind of decimal. You're going to feed it into your calculator like this in 2 pieces. One piece will read positive 3, cosine of 2 theta. And the other one will read negative 3, cosine of 2 theta. Now with the lemniscates, it's not going to connect in the middle. It'll be like a little gap. It won't do that little piece in the middle. But it'll give you enough. If you were doing it by hand, you'd have to do several values right there in the middle to get it to connect in the middle. All right, so clear that out. We're going to do 3 square root cosine 2 theta. Hello. All right, then go down, do the same thing. Negative 3. You won't do that part. You're going to have to connect that yourself. It'll just be this little piece right in there. Okay, if you want a bigger window, then you could try zoom standard, see what that does. That might make it a little bigger. A little bit. Or you could do zoom fit. Okay, what was, we got a 3 out in front, so see, that's how long the petals are again. The leaves as they call them, 1, 2, 3 units. All right, go to the next one. Let's see, was this multiple choice too? Yeah, so B. Go to 5. All right, this is the thing about, I grabbed this from my math lab. Number 5 is the question about how many petals or leaves are there on the rose. Let me blow this up because I tried to snip these questions out of my math lab, and this is obviously before I could figure out how to zoom in on that, make it zoom out. So these are tiny. All right, so let's see. Okay, so you got an A out here. The value of A determines the length of the petals, the length. The value of N, see they're showing you the equation right here if you can see it. I know it's very tiny. But the number out front, that's the A value. That tells you the length of the petals. And then the N value, well, it depends. If N is even, then this is how many petals you're going to have. Double N is the number of petals. And if N is odd, then you're going to have exactly N petals. That's what they're trying to get you to fill in with all these blanks right here. The value of N determines number of petals. Or you be prepared to say leaves or petals. I don't know what they're going to ask you for. They're doing leaves. There are blank leaves if N is odd. There's exactly N leaves if N is odd. And if it's even, there's the word even to finish that sentence. Then there's double N if that number's even. Okay, so I filled in that with the word length, this with the number of leaves, this with N, this with 2N. Okay, convert to rectangular form. Okay, you understand what I'm saying to you here? Where do they want me to go with this? Without me feeding it into you, you tell me what it says. What do they want you to do if it says convert to rectangular? Go into what form? X's and Y's, right? We're going to somehow try to get some X's and Y's to happen here. You do it by substitution. Weren't you given, how to get back and forth between the polar system and the XY system? All of those definitions were on page 1 of 9.1 that we just did. Okay, you got to keep reciting them to yourself. This is what you've learned so far about how to move back and forth between the systems. You learned that, let's see. What do you think right here? I want to pull this out of you. What do you think are the symbols in this equation that tell us we're in the polar world? What are the things that we have to get rid of? Because right now they are polar type terminology. The R, and what else? The theta. Okay, so somehow we got to try and figure out definitions that we can put in place of them that use X's and Y's. Like, for instance, do you remember that on 9.1, the very first page, that it said R squared is equal to X squared plus Y squared? So I'm trying to pull something from my memory to get this thing started. R squared is equal to X squared plus Y squared. All right, but I have an R to plug in for. So I think I know what I'm going to do with this. Here we go. And then just to keep in mind, cosine of theta. Remember when we were in chapters 6 and 7 and 8, how we always said that cosine when we wanted to give the, I know you guys do SOHCAHTOA, and you know that cosine is adjacent over hypotenuse. But then didn't we also learn X and Y type definitions? We said that cosine was equal to X over R. So we could try to do something like that. Watch. Got to get creative here. These are the things I'm thinking about for this problem. You got to get rid of the trig words, the thetas, and the r's. All of those are non-rectangular type entities. All right, so I'm going to come right in here, and I'm going to go for, in place of cosine, I'm going to put X over R. Clean this up a bit, realizing that 4 is the same thing as 4 over 1, so that that right side could really be called 4X over R. Then I'm going to do nothing to this R, but right now what I'm thinking of doing, I think this would be nice. How about if I cross multiply? Because if I cross multiply, won't I have R squared? If I swing this R right up alongside of the other R, and the minute that I have R squared, I can replace it with x squared plus y squared. So cross multiply going that way. I now have r squared is equal to 4x. Okay, so I'm going to bring it over here. Running out of room. R squared is equal to 4x. Then write in for the r squared, since I'm not allowed to leave any trace of any trig words, thetas, or r's. I'm going to put in place of it what's equivalent to r squared, which is this. All right, now you have to identify the graph. I think it would be a very good idea if you guys start trying to remember your algebra. That always seems to be what kills you, so I think you better put just as much work into this. Somewhere I want you to write this. I'm going to write it on the board because I don't know if I can fit it all. I'll write it on a piece of paper, and then you can go over it as you're going to need this for the parametric section anyway, which is 10.7, last section that I teach. Right now they're asking me what shape this is. Do you know what shape that is? Some of you probably have them memorized, and I'm going to say most of you don't. They go over this a lot in algebra, but I don't know how good your memory is. Do you know what that shape is? No? This is when you get quiet or you mumble. Huh? Circle. It's a circle. Okay? Now, I am all memorizing them. In fact, I want you to do that. Anytime that you have a square on both, because if there's just a square on one, it's a parabola. And both of the coefficients in front of the squared terms are the same number, and they're both positive. There's three things that have to be going on for it to be a circle. Because the minute that there's a minus in between the two squared terms, it's a hyperbola. Looks like two satellite dishes pointing in the opposite direction. Then it becomes a hyperbola. So that's kind of the giveaway, the minus. Okay, so why don't we write these down? Let's write these down so you can remember them. And maybe put them, I don't know, put them where you're going to be able to pull them out again, and they're not going to get lost in this section. Okay, circle will look like this. H and K is just where the center is. I mean, like a real basic circle that's positioned right at the origin. H and K is just the center. That's a circle that they've either shifted this way, or up and down. If you want to talk about what it looks like when there's no shifting of H and K, then in its most basic form, it would be written like this. Okay, and here's some things that have to be true. A has to be equal to B for it to be a circle, because the minute that A and B are not equal, but they're both positive and they're both squared, then it's an ellipse, a flattened out circle. So if A and B are the same, talking about the coefficients that are in front of the square terms, then it's a circle. So this has to be true. Both terms have to be positive. Both second degree terms. Okay, because these things that I'm telling you to check for in order to tell what shape it is, if these things are not happening, it changes into a different shape. So you have to know what to look for. So you have to have those memorized too. All right, so this is a circle. Might as well put the answer to this problem then. See that extra 4x that you see? I'm not going to get into completing the square right now. I will when it's demanded. That is also heavy-duty algebra. I'm doing it in my MAC1114 class right now. That just means that if you really wanted to graph this thing by hand, you'd have to complete the square. It would shift the center, but it would still be a circle. That's all that means when you have a mixture of second degree and first degree. You've got to complete the square. But anyway, all they asked us here was what shape this is. Okay, these are both positive, they're both squared, the coefficients are the same, so it's a circle. Okay, put that there. Let me finish giving you the shapes before I go on to number 7. Because you're going to have to convert to rectangular in that one section that we do in chapter 10 and tell me what the shape is. So I might as well tell you now what to look for. Okay, so let's see. What else do we have? Okay, well, we could have an ellipse. Kind of looks like a circle, but it's flattened out. That would look like this. Here the A is not, either A is greater than B. I guess I should say that it could either be A is greater than B or B is greater than A. Let's just say they're not equal. That'll cover both cases. That's what it looks like. I mean, without it having a shifted center, because this is what this means. You've taken it away from the origin. So without that, it would look like this. This would be a basic one. Like when you're in an Algebra 1 class, they keep you focused on that one. And then once you get to Algebra 2 or MAC1105, which is supposedly college algebra, then you start shifting things around. And then you do a bunch of this in pre-cal, the stuff that I'm talking about right now. Okay, so that's an ellipse. So basically it's like this. You know, if you're looking at it and you're thinking it's a circle, let's say you see something like this, just look for these two to be different. The minute that they're different, it's not a circle, it's an ellipse. Okay, this would be a circle with radius r, and this would be an ellipse, and then that would be A, and then this would be B. You don't have to put all that if you don't want to. Okay, what's the other one? The hyperbola. These are the three that you study the most when you're taking any kind of an algebra class. The hyperbola. The hyperbola looks like this. There's a fourth one that you study a lot. Okay, so let's say you had this. Oops, let me do x first. You have your x term squared, you have your y term squared, and then there's a minus in front of them. This is just one version of a hyperbola. What you need to look for is this right here. It's the only one I've given you thus far that has a minus in between. The minus sometimes happens. Now, if we were going into graphing these, I would go into all those details. You'll do that in pre-cal. You'll go over everything you learned in Algebra 2. But anyway, the minus can either be in front of this one or it can be in front of that one. Only one of them will have a minus. And that means you're talking about a hyperbola. This is one way that a hyperbola can look. It has these are called hyperbolic wings. You can have one that goes up and one that goes down. And as a matter of fact, the direction that these hyperbolic wings open is with respect to the positive expression. So if this x expression is positive, whoops, I just did that wrong. Sorry, I got to change this picture. I'm very, very sorry, but I should have opened it to the positive x expression. That should have went, for this equation that I gave you anyway, it would open like that. And then the other way this same hyperbola could be given is I could make the y expression the first one, therefore it would be the positive one. And then I could make the x expression the negative one, and then it would open like I just had it a minute ago, up and down. So whichever expression is positive, if it's the x expression that is positive, it'll open in a direction that has to do with the x-axis. If the y expression is positive, then it opens up and down with respect to the y-axis. Okay, so those are both hyperbolas. Okay, last one that you have to know. You got to know these four shapes, what to look for. Okay, let's review it. Both squared. Both terms are squared. Both terms are positive, and both the coefficients are equal. Okay, A is equal to B. You have two squared terms. Ellipse, almost like that. Ellipse is both terms are squared. They're both positive, but yet the A and the B value are no longer equal. Okay, hyperbola, the giveaway is the minus sign. But you will have both terms squared. And these A and B values, sometimes they're equal for a hyperbola, and sometimes they're not equal. You can have both cases. Either or. Either one of those could be happening. Okay, last one's the parabola. You need to know what to look for a parabola. You could either have y is equal to, something that looks like that. And you know with this one, this is the one you're probably most familiar with. You never, usually you don't graph the other ones that much unless you're in an algebra class. If this is positive, it opens up. If it's negative, it opens down. So it can be positive or negative. Okay, when A is positive, that's how you say A is positive, greater than 0, it opens up. When A is negative, it opens down. The other kind of parabola you can have, which is not a function, but they might ask you to graph it, is the sideways parabola, where the x would be here. So this is called, these are the vertical parabolas. They either open up or down. If they take the square and instead of putting it on the x, they put it on the y, then you're into the sideways parabolas. So when the A is positive, it'll open sideways and towards the positive numbers. And when the A is negative, it'll open to the left towards the negative numbers. So these are the vertical parabolas, either up or down, not both. And they're the horizontal parabolas, either to the right or to the left. Okay, there's a little catalog of the shapes that you should know from algebra, so you can answer the trig questions properly. So just like I'm always harping on you about knowing how to factor because it pops up, this is going to pop up once you get into these sections. Okay, can I switch that? Can I get rid of that? All right, let's go back to the problems that were here. I think we're on number 7. Yay, last one. Okay, so 7. For the given equation, find an equivalent equation in rectangular form and graph it. Okay, why don't you try this one yourself? See if you can get your brain working. Use what I've given you. Try to get rid of any evidence, any and all evidence of the R. You need to get rid of the word cosine of theta and replace it with X and R's. And eventually you're going to get rid of, I would do this. My suggestion is to try to plug in for this first. There'll be an R involved. Try to use the cross multiplication. You're going to have to do more arithmetic, though, than I did. And see what you can do with it. I want to see if anybody can get to the answer, and I also want to see if anybody can tell me what shape is it based on that little catalog I just gave you. See what you can do with it. Well, there's two things you can try to get to this answer. You can either try to replace this with x over r, and if that starts to get nasty looking, you make the decision whether it's getting worse looking or better looking. Or you could just jump right into the cross multiplying step where you go r times 1 minus cosine theta. See which one works. Let's see. I'm going to try both of them. Just so you don't keep banging your head on one particular way versus the other. All right. Did any of you try this? Where you went, cosine was x over r? I don't know if you tried that or not, but if you did, I don't know if you were led into this, like trying to bring these into one term. I thought this began to look pretty nasty. I mean, look what happens if you do it this way. If you do happen to call that x over r, then you got to call this something that has the same denominator, otherwise you bring them together. And you wouldn't be able to cross multiply if you didn't do that. So I called the one r over r, pulled these together, and then I was ready to start cross multiplying. Like I could just take, but look, this looks crazy because you could have went r times r minus x, r minus x over r times r. That would have been, and you still have an r there. You could get the answer this way. You could get the answer that way. Do you see what I just did? I just brought this right up alongside of it. There it is right there. The r's canceled, and I was left with r minus x, but you still got several more steps to go. I think this may be the shorter way to do it. I'm going to do it a different way. You're going to see that I'm going in this other way that I'm going to do. I'm going to get to this step maybe slightly sooner. Let's check it out. So another way I could have gone is start right back at the original. You're not done. You know why you're not done, right? Because there's still an r there. So you're not done if you do it that way. What was on the bottom? 1 minus cosine. If you didn't want to do the x over r thing, you could have just cross multiplied right from the very beginning. Instead of doing this business right here, where I did x over r, then r over r, you could have just jumped right into the cross multiplication. Would have looked like this. This might be shorter, this method. Then you could have went r times 1, r, minus r times cosine of theta, r cosine theta. Then this was one of the formulas that you were given in section 9.1, first page. They said r cosine theta is the same thing as x. See how quickly I get to where I was right here? So this one's less steps. Now, again, I'm not saying we're done. We need to get rid of the r. So what I would like to do is r squared. Right? So if you want to get r by itself and then square both sides, that'll get you ready for using that definition. Like I could swing this over here, leave myself with an r, bring this negative x over here, at which point it becomes positive x. I could, I'm allowed to do the operation, whatever operation I want, as long as I do it to both sides. I'm going to square both sides. I'm going to multiply, I'm going to just square this side, and I'm going to square that side. So I'm raising each side to a power of 2. Now I can get rid of my last evidence of the polar type information. I can replace r squared with its definition. And then I can square this out. Shortcut for squaring a binomial is square, double, square. Okay, let me practice that again with you because you should be using that by now. You square the first term. There it is right there. You double the number you see right here, which is 10, but you attach the x. And then you square this back term. The signs that go in between here, first and last term, always positive. This term right here will be whatever you see inside the parentheses. Okay, so can this be cleaned up at all? You see how you see a positive x squared on both the left and the right-hand side? So couldn't I just go minus x squared? And that would get rid of that term. Whenever you see the same term on both sides, you can bring them both to one side, which makes them disappear, and you end up with this. Okay, let's see if you can tell me which shape this is. What shape is that? Parabola, circle, hyperbola, or what? Parabola. So you got to memorize those. When there's only a square on just one of them, not both. See, there's only a square on the y and not on the x. That's what you're always looking for. How many squares are there? When there's no squares at all, it's a line. When there's a square on just one of them, it's a parabola. But you need to know what kind of parabola. This would be sideways parabola whenever the square, and it would point to the right. And that's because there's no negatives here. Okay, that's it. For section 9.2, we're right on track. Make sure you stay caught up with me because you really got to do well on this last test. You only have one test left and the final. You got to make those work for you. Everybody have a beautiful weekend or beautiful rest of the week.